So in the last video, we went over some, basic definitions of what a logarithm was. Now let's go over some log rules, which are really, really important. So let's go over log rules. Log rules. I would say these are really, really extremely crucial. So the first log rule is the following. So log of x plus, now I'm just going to say this is base 10, okay? So log of base 10 y is equal to log of base 10 x times y. Okay, so let's sort of give an example. Just do an example of this. Let's say I have log base 10 of 5 plus log base 10 of x. What that means is it's just log base 10 of 5x. Okay? Keep in mind that when we're doing this, there's the coefficient in front has to be 1. If it's a coefficient of 2, you cannot do this. And I'll show you later on like how we can do that. So in other words, here is 1, here is 1, so it works out. But if this were 2, we would not have this solution. And I'll explain like how we can do that in just a bit. So that's the first log rule. The second log rule, let's do log base 10 of x minus log base 10 of y. Still a little lagging here, but anyways, it's equal to log base 10 of, now it doesn't have to be base 10, I just put base 10 over there, but it can be any base, so I could put a, b, c, whatever I want, but I just put base 10 for now. So it could be 1, 2, 3, e, doesn't really matter, this applies for all bases. Here we go, this applies for all bases, and this is equal to x divided by y, right? So for example, if I had log base 10 of, say, 20, okay, minus log base 10 of, say, 4, this would equal to log base 10 of 20 divided by 4, which is equal to log base 10 of 5. And that's the second log rule. The third log rule, I would say, is very important. So log base 10. Now, keep in mind, once again, this is just not base 10. It could be any base. I'm just choosing 10 for now. And what happens is that when there's an exponent, this exponent, when you log it, it can come down. So this would equal to n log base 10 of x. Okay. So for example, if I have log base 10 of 2 to the power of x, and I say I want to bring that exponent down, then you log it, which we've done basically right here. I'm just going to put brackets around this, and brackets around that. What we've done here, we're allowed to bring this exponent down, so log base 10 of 2. Okay. The next rule is basically what happens if we have a coefficient in front of there. So let's say instead of x to the power of n, we have ax to the power of n. So keep in mind that first of all, these two are being multiplied, right? So it's not like, the temptation is to, oh, because I see an n over there, I can bring that down, and therefore it's log ax. Don't write this down. This is wrong. This is completely wrong. Okay? This is completely wrong. So what you must do is first you need to split these two apart. So because these are multiplied, so kind of like if we go back to the addition where these two were being added, so we kind of have to go in reverse. So if these are being multiplied, we have to go in reverse and split them first and then bring the n down. So I'll show you what I mean in a second. So what we'd have to do here is first we have to do log, okay, I'm just going to put base 10 over here, log base 10 of a plus log base 10 of x to the power of n. Now, if we want to bring this n down, we can do so. So this is log base 10a plus n log base 10x. So I hope that was helpful in explaining that. The next thing we want to go over is a very important rule known as the change of base. Okay, So say the rule is, let's say we have log base A B, okay? What this is equal to is log B over log A, and we can choose any little base that we want. So kind of confusing, and you're probably asking, well, how is this useful? So let's just give an example of how this would be very, very useful. So let's say, for example, we have log base 9, 27. And let's just say you have no idea how to do that. 9 to the power of what will give you 27? You have no idea. So what you can do is you can use the change of base rule. So what that would do is log of 27 over log of 9. Now what it allows you to do is you can choose any little base that you want. A base that I know would kind of work for both is 3. And the bases have to be the same, by the way. You can choose any base you want, but they have to be the same. So we can choose 3. So I know that 3 to the power of 3 will give you 27, so this is equal to 3. And 3 to the power of 2 will give you 9, so this is equal to 2. So basically, the answer to this is 1.5. You see how that was hopefully helpful? Okay, and the last important rule that you need to know is the following one. It's a to the power of log, oh shoot, what did I do here? Let me just erase this. It's a, here, it's a to the power of little base a x. So in other words, a to the power of log a. So if this and this are the same, this is actually equal to x. So for example, if I had 5 to the power of log 5, 2, right? So the whole thing is in the power, is in the exponent. So this is my base, and then there's another little base over here. This is actually equal to 2, okay? I'll give you another example, and I just want you to be sort of careful. So say, for example, I have, say, 7, okay? And I have to the power of 2 log 7, and it's 4, okay? So your first temptation would be to think, oh, well, here's the base of 7, it's log to the power of 7, so it must equal 4, and that's not correct, because there's a little 2 there that's going to bother you. So the first thing you need to do is make sure that there's no coefficient in front of the log. So using the log rules, we can actually bring this coefficient back up there. So this would be 7 log base 7 4 squared, right? And now we can see that this base and this base are the same, so this is equal to 4 squared, which is equal to 16. Okay? So just be careful, make sure that the coefficient there is 1, and if there is a coefficient, you can bring that up there, so that becomes 4 squared. This is part of the log rules, just to clarify which log rule that is. It's this one. So if you can bring it down, you can also bring it back up, which would look like this. So they work both ways. So if it's down, you can bring it back up, and that's where I got. That's why I was able to push this 2 up there, so it became 4 squared. And since both of these are the same, I'm left with 4 squared, and therefore 16. Okay, so let's just do a couple of examples, which I think will be helpful. So say, for example, let's say log base 5 of a is equal to r, okay? Log base 5 of b is equal to s, and log base 5 of c is equal to t, okay? So what I want to do is, in the following questions, I want to express everything in terms of r, s, and t. I don't want to express it in terms of logs. I want to express it in terms of r, s, and t. Okay? So let's do one example right here. So say, for example, I have log base 5, and in brackets it's a cubed b 4. Okay? So if you remember the log rules, I'm allowed to split this, right? So first split, don't bring the exponents down. Split them first. So what this would equal is log base 5 a cubed plus log base 5 b to the power of 4. Now that they're split, I can bring the exponents down. So this is equal to 3 log base 5a plus 4 log base 5b. Okay, so we can observe that we have these separated. So we know that log base 5a is equal to r, and log base 5b is equal to s. So this is equal to 3r plus 4s. And I'm done, because I want to express this only in terms of r, s, and t. Okay? I'm just going to, here, I just want to copy this part, which is all of this. So let's see if I can just copy that, and I'll move to the next slide and see if I can just paste that. Edit. Oops. It tells me I can't paste it. Oh yes, I can. Okay. And there we go. Okay. So here, that was my first example. Now the following is my second example. So let's do B. Okay. So here's my example: log base 5. Okay. And you must make sure the bases are the same, right? So in this case, it is. So a cubed b to the negative 2 over c to the power of 4. Okay, so once again, you can just split this, right? Because these are multiplied and because this is divided, if you remember the plus and minus rules, I can just write this out in one statement right away. So I'm just going to write that here. So ignore this. This is going to be log base 5, okay, a cubed, and it's going to be plus because it's multiplied in the numerator. Okay, anything in the denominator comes with a minus. So this will be log base 5b to the negative 2 minus log base 5c to the power of 4. Here's the general rule. Whenever you see a log function that's sort of like a fraction, the easy thing you can do is anything in the numerator basically will start with a positive. Anything in the denominator will begin with a negative coefficient. Okay? Now, the next thing, I'm just going to scroll down a bit. The next thing is I can just bring down these exponents. So it's 3 log base 5a. And since I bring down the negative 2, it's minus 2 log base 5b minus 4 log base 5c. Okay? And as we know, we said this was r, this was s, and this was t. So this is basically 3r minus 2s minus 4t. Okay? And that's basically the solution. I have one more example to show you. Let's see, that there. Okay. That's r, s, and t. So keep in mind, log base 5a is r, log base 5b is s, and log base 5c is equal to t. Now, here's my last example, which is c. So log base 25 a to the power of 4. Okay, now I can't really apply anything here because this is a base of 5 and this is a base of 25. They're different. You can't really do much with it. I mean, sure, I can bring the 4 down, but I can't say that log base 25a is equal to r. I just can't do that. So here's where the base change really, really helps. So remember that rule where if you see something like this, this just becomes log a to the power of 4, and this becomes log 25, and I want to change the base because I don't want the base to be 25. So I can choose a base of 5. So what this does is now this sort of makes life a little bit easier for me. So I can bring the 4 down. So that's 4 log base 5a. And log base 5 of 25, 5 to the power of 2 will give you 25. So this is 2, right? So this is 4 log base 5a is equal to 2. So in other words, this is 4, and we know that log base 5, this is 4r over 2, which is basically equal to 2r, and we're done. All right, so that's these log rules for now. In the next video, I'm just going to go over why logs are useful and how we can use them. Okay, So see you in the next video.